I think a row scope that we have access to here. Otherwise, we wouldn't be able to call waste. I want to set the selected content color to our sand yellow. So this is for the line here and for the text color. And the unselected content color, so when a tab is not selected, we set this to black, but with 50% of alpha. So color, black, copy, alpha, 0.5f. Then the text for this tab will be a string resource. Let's create this here in our values strings XML. Let's create 2 of these. On the one hand, search results. And on the other hand, for the favorites. Then quickly make this module again. So we generate these string resources, go back here, make this bigger again, and we get an error that is expected. In here, we can now refer to these just generated resources with ras.string.search results. And the modifier of this text will be modifier.padding. And we again give this 12 dp of vertical padding. And the second tab will look exactly the same. So we can just copy paste this, work with that, just replace this one with 1. So this is selected if the select tab index is equal to 1. If we click on it, we want to select tab number 1 and the text would be favorites. And if we now refresh our preview, we should hopefully see exactly that as well. We should hopefully see a tab layout. Yes, just this purple bar should not be there. This should also be orange. I think we need to change this for the tab row, which is the container color. No, the container color is obviously what's behind. If we set this to desert white, that is what we should definitely do. The content color to our sand yellow, and then refresh this. What happens? No, and I actually just checked that. We do need to override this indicator. So that is how this thing is called, the currently purple thing. That is a tab indicator. We can override with this indicator lambda, which gives us a composable lambda, to have one from tab row defaults that tab, that secondary indicator it's called. We set this to modifier, dot tab indicator offset. And this one actually gives us access to tab positions, which is, if we take a look at that, a list of tab position. So where each tab is in our tab layout. And we can now use this to properly offset the indicator. So let's actually not do this so we see what happens by just giving this a color of sand yellow. If we do it like this, then you can see this is a completely sand yellow, which might also be because I set the content color there. But no, and we actually do need to pass in this modifier tab indicator offset. And here we can then refer to the specific tab of our selected index. So state selected tab index. Refresh this again. And now you can see it's properly offset. So it just uses the proper position and offset information from the tabs that we already get from the Lambda itself. So we don't need to worry about that, but we do need to use this custom tab indicator offset modifier to properly offset this. Okay, below this tab layout, I just want to have a little bit of spacing. That means if we have this tab row here, then here we want to have a spacer where we say modifier is modifier.height with 4 dp of spacing. And what comes here will now be a horizontal pager. Why do we need a horizontal pager? Because this tab row from the material library is really just what it has. It's really just a tab row. It adds these tab-like components, but it does not yet allow any swiping between these tabs. It really only adds 2 tabs and lets us click on these. But if we want to be able to actually swipe between these pages, then we do need a horizontal pager, which is pretty much just a container in which we can put a composable, and that container lets us swipe between multiple pages of composables. In our case, just our search results and the favorites list. In order to now declare this horizontal pager, we can work with a horizontal pager, surprise, surprise, which now takes in this pager state. This pager state lets us then also control which page we are actually inspecting, how many pages there are in the first place, and I would like to declare this at the top of our screen, somewhere here. Val pager state is equal to remember pager state, which gives us this lambda here in which we need to pass in the page count. So in our case, just 2. The initial page can stay at 0, and the offset fraction, we don't need to change anything about that. We just want to have 2 pages, and then pass in this pager state down here. Give this one a modifier of modifier fill max width and a weight of 1f, so we can fill the remaining height of our screen. And then we get this composable lambda in here. And what we now put in this lambda here, it will be our current page. So we do get the page index here. So either 0 if we are on the first page, or 1 if we are on the favorite section. And depending on this page index, we now want to show the right page. So we can say when page index, if that is 0, we want to show this composable. And if it's 1, we want to show that one. If it's 0, then that means we are here on the first page where we show our search results. There we need to have another check, because if we are currently loading those search results, we want to show a loading indicator. So we say if state is loading is true, then show a circular progress indicator, which we actually want to center on the screen. So we might want to actually put all this stuff in a box. Modifier fill max size. And we give this a content alignment of center. So we just center everything here inside of our box. And when then the page index is 0, this indicator will then be centered. If it is, if we're not loading, so else, then we actually need another little when expression, because depending on what our search results are, we want to show a different thing. So you can see this if we search for something here where we probably don't find any search results, then we display such a text. This is something we would need to put in this box. And if there are search results, we obviously show them with our list. And if there is an error, we also want to show this. So if we, for example, turn off our internet connection and we search for something, Harry Potter or so, then we get an unknown error occurred, or whatever kind of error message we choose for that. So here in this when expression, when the state dot error message is not null, so that there is an error, then we just show a text that tells us this error. And since this state error message is now a UI text, not a string yet. This UI text is just a wrapper, as I said, around a string resource ID. We can now take this and actually unwrap that with asString, which is a composable function, and will then simply take the string resource ID. And if it, first of all, check what kind of UI text this is. If it's a dynamic string, it will return the value right away. But if it's a string resource ID, like it is here, then it will return the string resource with this ID instead. So going back here, we can then also change the appearance of this text a little bit. First of all, setting the text align to center, not snap position. Text align is text aligned at center. And the style of the text can be material, theme, typography, headline small, for example, headline small. And we might also want to give this an error color. So material theme, color scheme, error, like this. Similarly, you want to do this if there are no search results. So if state search results is empty. So we search for something, but nothing is available. Then we also want to show text, not the error message in this case, but rather a string resource. String resource res dot string, and how do we call this? No search results. We can then go to strings XML, duplicate the last line, create a no search results string resource, and say, oops, we couldn't, or not we, let's say, oops, there aren't any books for your search query, something like that. Then again, make this module again, and after that we can import this. Here we go. Do we get the import? No, it's not done yet. There we go. Do we now get this import? Yes, we do. Alt enter, import the string resource, and for the final state, so else, that means we successfully found at least one book with our search query. In that case, we want to show this list of books, of course. So we say book list. The list of books comes from our state dot search results, we called it. When we click on a book, then we do want to trigger our onAction lambda, where we say book list action on book click, and we pass in it, so the book we clicked on. The modifier can just be modifier fill max size, and that's already fine. For the scroll state, I want to pass something. Let's say lazy list state. I want to declare this up here. here, val lazy list state is equal to remember lazy list state. The reason I'm creating this, I actually need two of these lazy list states. One for the list for the search results and one for the favorite books. Let's actually change this to search results list state or so. The reason I'm creating this is that if we've scrolled down a little bit and our search results change, for example, we search for Python now, then you can see it animates a scroll to the very first item index. So in order to actually force animation or force animating towards a specific item, we need a lazy list state. So we can have a launched effect block here whenever the search results change. So when we have different books in our list, then we want to say search results list state, animate scroll to item, and we want to animate to the very first item. Down here in our pager, in this book list, we now pass our list state. And for index number 1, for our favorites here, when we are on this page, then we also want to show a book list. So we can actually have something similar. So also if there are no books in our favorites list, so if state favorite books is empty, then we just want to show some kind of text here. So we can just replicate this one here. No search results. We probably should change this to something like you haven't saved any favorite books yet. And here we can say no favorite books. And again, same thing. That is a bit annoying with having to rebuild all the time when creating a resource, but we get a lot out of that by being able to share these resources. The rebuild is still going on, but we can already set this to no favorite books. And in the else case, we can probably just copy paste our book list from up here, put this over there, and just swap this out with our favorite books. Here we need to also pass in a different scroll state. So we can say favorite books list state, something like that. Scroll up, duplicate this one, call it favorite books list state, and we are ready to go, I think. I think this should be the screen. We can also refresh our preview in a moment. Rebuild is still going on for me. All right, and now after rebuild, you can see the preview actually loaded and it looks slightly off. So if we go back to the search results, these items all look a little bit like not so high as these are. And I would say we check why this is. First of all, let's vertically center these, and there's also there's not enough horizontal spacing. So let's fix these easy things first, I would say, by going to the book list item. And here in our row, yes, the root row, here we need to make sure that we vertically center everything like this. We can also give this row some horizontal arrangement spaced by, let's say, 16 dp. If we then refresh this preview, we should already see that everything is hopefully centered vertically. And yes, not so cramped. It seems like there is some vertical spacing here. I mean, the odd thing about this is that this box here, if we click on that, then that is the surface. That is smaller than the actual area that gets drawn. And I'm not sure if this is actually an issue in our code or an issue with the preview. So I would suggest we just try to launch the app as it is with our dummy books by going to our previews, taking this private val books and cutting this out, putting this in our book list state like this. Let's just have our dummy books over here, make this thing public. It's really just for development purposes. Here we then need to import these books with Alt-Enter. And then we can say, okay, the initial search results are just our dummy books. If we then launch this on our device, let's see what happens, because I think everything else should already be set. Okay, we do get a crash. Why is that? Because of probably missing internet connection. Let's go to manifest, add a user's permission and say, we want to use internet. That was probably it. Yes, it was. And here it actually looks different. That is good. So it seems like the preview here has its issues with the compose multi-platform composables. You can see the images don't load because we have invalid URLs. So that makes sense. And the rest is looking pretty much like before. Going to the favorites works. It just doesn't show the favorites list yet, or did we also pass that, also pass in our dummy books for that? No, that one is an empty list. So we still need to check why that doesn't work. Oh no, okay, when this error book actually loads, then we do get this extra spacing. So it seems to be related to somewhere here where we check whether the search, no, actually in our list item where we check if we successfully loaded the result. Somewhere here it seems like we have too much padding or so. Alright guys, I did not expect that finding this padding issue here would be that difficult. I just spent 1.5 hours to actually track down why, only for error images, we get this kind of extra padding here. You can see I opened the layout inspector. And for some reason, only for these error images, there's this extra kind of spacing around this image, which does not happen for the actual book covers. I really copy-pasted my exact composable that I have in my sample code in here. Same issue. I double-checked everything that I could. Same issue, and I ended up finding the issue, so we can fix this luckily, but I still don't understand why. I assume that it's either a bug in Coil, a bug in Compose resources, or that I just completely missed something here. But I know that people like when I actually fix such things also here in the video, because I think it's important to show that YouTube is also not always sunshine and rainbows and that we just type the code from beginning to end and then it magically works. That's also not the case for me. Of course, everything is prepared here. And even if everything is prepared, such issues happen and I need time to debug these. That's completely normal. So nobody needs to feel bad if that happens to you. That happens to all of us. Let's actually take a look at what the issue is, or rather how we can fix it. We can fix it by taking a look here in our book error 2 XML. For some reason, this vector drawable does not like being 512dp wide and high. If we change this to something smaller like 256dp, which by the way, I don't have that way in my prepared code. I actually just copy pasted this file. So my prepared code, I have 512dp for both of these and it works just fine. It does not have this extra padding for these error images, but here I need to change this. I don't know why. I'm using the same versions for Coil and all that stuff, but if we change this and then actually rerun our app, then take a look here again. Let's also get rid of the layout inspector so we get this a bit larger. Then we should hopefully now get a working list item. I mean, they are working, but they should look a little bit better without all that extra spacing. And there we go. You can see now it looks exactly as we wanted. I have no idea why this actually causes an issue because we gave our image actually a fixed size. So here in our book list item, the image is inside of this box, which has a fixed height. So it's technically not possible to actually exceed that height, no matter what kind of image we put in there. But for some reason that still happens. So I can only explain that, as I said, either a bug in Coil, a bug in Compose multi-platform resources, or I'm missing something. If you know the issue, comment below. Would be very interesting to know. But I think this is also not something that we need to waste hours on. So let's just go on with building the book app, because now we actually have a completely working book list screen where we can scroll through all of our books, or dummy books at this point. We can actually change here to the favorites. You can see this does not yet update, and that's something we'll do in a moment. Maybe we should also change the text color of this one here to black, so it doesn't show up as an error. We can do this here in our book list screen by scrolling down. Let's shrink the preview a little bit so you get to see more code. Here for the search results, when these are empty, no, actually not these, but when the favorites are empty, then I want to get rid of the text color here. So it will show up in black. How do we now implement that when we switch the page, then we also update our pager, and that when we click on our pager, we also switch the page? Because that's the only bit of functionality missing here, apart from, of course, loading the books. We need to do this with some launched effect blocks, because on the one hand, we need to listen to our current page, which will update when we swipe here in our pager. And on the other hand, we need to listen to the selected tab index of our tab row, which will just change when we click here. And the way this works is pretty simple. So it's kind of a two-way binding, we can call it. We have a launched effect block here where we listen to our selected tab index. So whenever that changes, this launched effect block here will be called. And in that case, when we click on favorites or search results, we want to use our pager state to animate a scroll to a page, and the page will simply be our new selected tab index. just like that. So this will fix that if we click on something, we also switch the page. And now the other launched effect will be for switching the page, that we also update the selected tab up there. Here, launched effect. This will now require the actual, the current page. So pager state, that current page. Whenever that changes, which will update when we swipe the pages, then we want to check if we are currently not scrolling. So if pager state is scroll in progress is false, because only when we really stop the scroll, then we want to actually update the tab row. So here we need to send an action to our view model by saying book list action dot on tab selected, and the new selected tab in this case will then be the pager state current page. So just the new page that we swipe to. If we launch this, then we should be able to check this. There we go. So if we swipe, then no, it does not yet happen that we actually see the tab row. If we click here, that works. I think this might be because the current page updates before this Boolean switches to false. Let's try if this works if we put this outside this if condition and launch this again. So there we go. We swipe. Yes, now it works just fine. And we can still click here and still swipe. Yes, now it works. So the scroll check apparently wasn't necessary. So I think we can start the next chapter of this course, and that is to start working on our data layer, on the functionality that we can actually fetch our book data from our Open Library API and then somehow display that in our UI so that we are able to actually search for books, that we call that we properly map everything to state in our book list view model, and so on. So to just show you how this API works, which API we're actually using, I'm here on this Open Library website. You can see that's just openlibrary.org, completely free. As I said, you don't even need an authentication for that. You can just call the endpoint. And the way this works is we do have this search.json endpoint, and we can just attach this title here. So for what we are actually searching. And for example, if we say Harry plus Potter, execute that. Then after it loaded, we get all of our books here from that endpoint. So this is now the JSON structure that we need to kind of replicate in our source code in Android Studio. Of course, not exactly the same structure as here. So there's a lot of information for every single book, but only those types of fields here that we're actually interested in. So specifically those that are also part of our book model. So how does this work with the architecture that we've chosen? This works with so-called data models. So you've already learned about domain models. A domain model is in the end what you've seen here, this book model, for example. So really just a pure Kotlin data class representation of a core concept of our app, of what a book is. Now, a data model is something similar, but it contains implementation details. Specifically, how our JSON field names are actually like, in which format the JSON structure is in, and so on. So what we want to create for this book is we want to have an equivalent data model that we can then use to take our JSON structure that the API responds with and parse that into our Kotlin data class. And we call these data related models, at least if they come from a network, we typically call these DTOs, so data transfer objects, because these are transferred via the network. You'll notice that these can be quite similar as this domain model here, but I'll share why we have two types of models here in a moment. So here in our data package, what we want is we want to create, let's actually create a DTO package in there for all of our data transfer objects. And in there, we will now have a data class called searched book DTO, for example. So just one book entry from our search response. This will be a data class. And since we're now using Kotlin X serialization to actually parse the JSON into our Kotlin data class, we need to annotate this with serializable. This is a requirement from this Kotlin X serialization library. And now here in this data class, we pretty much just want to look up our JSON structure. So we are now actually trying to parse such an object here in this docs list, trying to parse that into such a data class that we've just created in our DTO. You can see we have the title, which is interesting for us. We have a lot of IDs from Amazon, ISBNs, and so on we don't care about. We have the publish year, for example. So we now want to actually extract the data that we need here from this JSON structure into our Kotlin data class. On the one hand, each book will have an ID in form of a string. And we also want to annotate this with serial name because remotely these IDs are actually called key. I still prefer to work with ID here So with that, we just say, okay, in the JSON it's called key, we want to call it ID. Then we get the title, which is a string. Title is also called like that in the JSON structure, so we don't need the serial name here. We do want the language, actually the languages, because there could be multiple languages, which is a list of string that can be null. So this is not returned for every book. We have the cover alternative key, which is an integer and nullable. So this will be the cover key, which we'll later on need to actually fetch a book cover, since that's not contained in the response there. So this will have a serial name called cover_I, which I just like to call cover alternative key. Makes it a bit more clear. Same thing for the author keys. So serial name author_key, which is actually a list. So author keys, list of string nullable again. We have the author_name for our author names, again, plural. We then have a normal cover key. Let's also duplicate this again. Cover key, which is called cover_edition key. This will be an integer again. So a nullable integer. There are just two of these cover keys. We'll first of all try to fetch the book cover with this key. If that fails, we'll try it with this key. And if that fails, we will display our error image. In general, the API design of this open library is not that good. You will also notice this later with an issue that we have with this API that we will need to work around. But for now, we can just proceed here. So we get the first publish year, which will be our publish year. Let's call it first publish year. We have our ratings average, which is a double and called ratings average. We have our ratings count, which is an integer. Call this ratings count. And we have two more that we care about. On the one hand, the number of pages median, which we want to call num pages median, and that is an integer nullable. And the last one that we care about, at least, is the edition count. So the number of editions, And I would say for consistency, we can also add these serial names to these here by saying this is our title. Oops. And here, I think that's actually called language, even though it's multiple ones. So let's also add the serial name here. So we now have our searched book DTO. This looks very similarly to our book model, except for these annotations. So why do we really work with two models here? Couldn't we just add these annotations here to this book model? So to make this, a serializable and so on. We could, but we would violate this architecture because, as I said, the domain layer is really meant to be completely isolated. It really shouldn't have any references to external libraries, to implementation details. And while we have a single module project here, we would technically be able to use those here, but very often in practice, you don't have that. So you have your domain layer as a separate Gradle module. So you also have to add your own types of libraries for this domain module. And then you wouldn't be able to use data-related references here by default anymore. And that's the intention of it. Because the purpose of this is of having two models here is that when implementation details change, let's say the backend team says, hey guys, I actually renamed the key field to ID. What we as app developers then have to do is we have to hop into our code and we need to change this here to ID so that our code doesn't break. And such changes in implementation details like the JSON structure should not have an impact on our domain layer. They should not require changes in the domain layer. And that is why we really want to keep it like that. Also, if certain implementation details or certain libraries change, if you say, I want to swap out Kotlin actualization with, I don't know, Moshi or JSON, well, then you also only need to change your data layer. Your domain layer is completely isolated of these dependencies, so you don't need to change anything there, and also not change anything in the presentation layer, since the presentation layer only makes use of the domain models again. Something else we now need is, if we take a look in our browser again, the searched book DTO is in the end what starts here from this JSON object. However, the actual JSON response that is returned is this outer one here. So we also need such a DTO for that outer response, which contains this docs field, which then contains a list of our searched book DTOs. So let's go here in DTO. Let's have a search response DTO, for example, which will also get our little serializable annotation. And in here, we will then just have our docs field, or let's call it results to be a bit more expressive here. This will be a list of our searched book DTO now. And we can annotate this with serial name to encode the remote JSON field name, which is docs. So this was what the API will respond with. And this contains our desired list of searched book DTOs then. Okay, so the next step is now to actually implement the functionality that really makes that actual API call and parses the JSON response into this object. And that also goes in our book data layer here, where we can just say, okay, maybe create a network package or so. And in here, we will put a class called ktor remote book data source, because that's exactly what it is. It's a data source. So a source of books, it's remote, and we use ktor for that. So this is a typical naming I choose for these specific implementations of a data source, since the class name immediately makes clear what will be inside. And this class will take in a reference of an HTTP client. So from our ktor client, this is the main instance that we need to use in order to make actual API calls and fetch data that way. And technically, we can just create a suspend function in here, which we call search books, for example. That obviously needs the search query. And we could pass an optional result limit, so a nullable integer for just how many results we want to have in the response. Let's format that a bit like this. And what will this now return? Well, this will return a result, our own custom result class that takes in two generics. A result that holds our search response DTO. Oh no, actually not, because that would be a violation of our architecture, which you will see in a moment why that is. Instead, what we want to do, what we want to return is a list of books. So our domain model. If there was an error, so the type of error codes of error enums that we can return here in this search books function, well, those are data errors which we need to create. That is now how this result class works that I added before in our core package, domain. And here we have this result class, which really just wraps around either a successful piece of data, a list of books, for example, or a specific error that must implement this error interface we have in here. It's really just a marker interface. And the way this now works is, if we want to extend this, for example, with a set of network-related errors, then we can go in here, we can create something like a data error, make that an interface, a sealed interface. And a data error could now be a remote error, but it could also be a local error. So if we're dealing with a database and the storage is full or so, then that would be a local data related error. If the API responds with some kind of invalid status code or there is no internet connection or so, then that is a remote related data error. So in here, we can declare an enum class called remote for the remote errors, which is now a data error. And this data error, very important, must also implement our error interface. So we are able to pass that as a valid error to our result class. And let's now think about what kinds of remote errors we care about. For example, request timeout. Too many requests. So in case the API has some kind of quota and you exceed that quota, then that might be returned. For example, something like no internet, if you don't have internet connection. Something like server. So if there's any server-side error that we don't really have an influence on, then we also want to know that, of course. Maybe also serialization-related errors. So if JSON parsing fails for some reason. And lastly, let's have some unknown errors for everything else. We can also already add another enum class here for local data errors, in which we just have disk full or unknown, like this. What this now allows us to do is, in our ktor remote book data source, we can now make this return a data error.remote. So here in this function, we can now make our API call. We can check for the result. We can properly retrieve the list of books in our response. If so, we will return this as a result of success with this list of books. If something failed, we will return the proper data error here from the enum class remote. And for a simple app like this that really just needs to make use of two different API calls, one for the book search endpoint, one for the book detail endpoint, we could really just type this off here. But as I said, I really want to teach you how I would also handle this in a growing app, in an app that scales. And that is why I will introduce some utility functions that I typically use for my bigger projects that I've also shared in my Big Essentials course, because that will really make your life easier when you work with maybe 10, 20, 50 or more than 100 endpoints, which can quickly be the case in a growing app. So what we want to do is, in core, we create a data layer for shared data related logic utility. And in there, we will have an HTTP client extension file. So here we really just define extension functions for the HTTP client or just other HTTP client related utility. For example, that we have a suspend inline function. We say reify t, and no worries, I will explain this in a moment. Call this response to result, where we pass in a certain HTTP response. And what this will now return is a result from our domain package here, a result of type T or data error remote. So this function is now a utility function that takes in an HTTP response, so any type of response that came back from an API, no matter what kind of API call that was, it will try to actually extract the data out of that HTTP response, so the actual JSON body, and parse that into our type T that we expect here. The reified is needed because we need the type information of this generic argument inside of this function here, which would normally not be possible. With reified it is. Inline is also needed together with that, and it's suspending since the function or the parsing process is a suspending function here. But in the end, this is really just a when expression. So we can return when the response status, that value, so the actual returned HTTP status code, if that is in the range of 200 to 299, that means the response was successful, because if an HTTP status code starts with a 2, that indicates a success. In that case, in here, we now want to try actually parsing the JSON body into our type T. So we say result success, and we say response.body as type T. So we just try to actually parse that response body into our T data class, and this would then return just our Kotlin representation of the JSON response. If that fails, it will throw a node transformation found exception, and in that case, we can then return a result error instead, where we say data error remote serialization. That is the specific error that happened in that case. And now after that, when things went wrong, then the status code does not start with a 2. Instead, it will start with something like a 4. So that will be a client-side error, something that is our fault, that we made a wrong request or so. For example, 408 will mean request timeout. In that case, we can then return result error, data error, remote request timeout. Something like 429 will be too many requests. And let's take a look what else we have in here. So we have a server-side error, no internet error that does not have anything to do with the status code that is returned. That is something we need to check when we make the request, and unknown errors. So in here, if the error is in 500 to 599, if it starts with a 5, that means server-side error. So something on the server went wrong that is outside of our influence. So we say result error. Actually we need the in keyword here. And then we want to return data error .remote.server. And in all other cases, we say result error, data error, remote, unknown. So in that case, we just display a generic error message. Of course, we could check for every single status code that could be returned here, but I always decide about how fine-grained I do this, depending on whether I want to show different types of error messages for these different types of errors. So if there is no benefit to the user of knowing the exact error, what went wrong, then I also would just show a generic error message, which can sometimes also be better security-wise, since you're not revealing why something went wrong. All right, that is one utility function that I want to create. Another one is now a function that safely executes an HTTP call and catches the necessary exceptions there. Will also be a suspend inline function, also with a reify t for the same reasons as below, and we call this safe call. This will get in an execute lambda, which is meant to execute the actual call, and this lambda will return an HTTP response. And again, put this on a separate line. And this will then again return a result of t and a data error network, remote I called it. And all this will now do is it will get the response, or try to get the response from our execute lambda, which executes the request. So it's a lambda, so we can dynamically use this function with any type of request that returns an HTTP response. But this function will now catch certain exceptions that could happen there. On the one hand, a socket timeout exception, for example. In that case, we want to return a result error, data error, remote, timeout, and actually return that here. If we get an unresolved address exception, then as long as the server is actually live, this usually means that there is no internet connection. So then we want to return result error, data error, remote, no internet. And if we get any other exceptions, then we want to return result error, data error, remote, unknown. Here it's important, if we catch general exceptions in a try and catch block for a suspending function, which this execute function could be and will be, that we also call coroutine context ensure active. I won't go into the details here, but what could possibly happen here is that we accidentally catch cancellation exceptions. So when a coroutine is cancelled in Kotlin, it will, the currently suspending function will throw a cancellation exception, like this execute lambda, the API call. And if we catch that, then we can break this cancellation mechanism in our app, since the parent scopes of this coroutine might not be properly notified about that. That can lead to several issues. I made dozens of videos about common coroutine mistakes. I have a coroutines masterclass, which I also linked down below. So won't go into the details here, but this is something we have to do. All right. So this means if we did not return at any catch block here, we successfully got a valid HTTP response. And this we will then simply return by putting this into our response to result like this, which will also return the same type of result here. And now we have very handy utility here that we can use to go back to our data source and actually execute this. So here for search books, we can return our save call function, which has this lambda. And this lambda now needs to be an HTTP call that returns an HTTP response, for which we can then use our HTTP client. We call get, so it's a get request. We need to pass in a URL string, so the actual URL we want to make a request to. We can also have our base URL here, so private const val base URL, and that's simply https openlibrary.org. And then we can say, okay, our URL string is, actually our base URL search.json, that is the URL that I showed you before. And then here we can open a block of code to configure that request a little bit. Specifically, you want to pass certain request parameters. On the one hand, Q for query, where we pass in our query. Our limit, so how many books we're interested in for this request, will be our result limit if it exists. We want to pass in our language, so the language of the books we are looking for. If you come from a different country or you prefer books in your language, then feel free to adjust this. We will use English here, of course. And lastly, what will be quite useful is that we also pass in this fields parameter here to tell the API which fields we're actually interested in. So all the others then won't be returned. You just saw how big the response was with all those Amazon IDs and so on. We don't care about that in our app, so we also don't need to transfer all that unnecessary data. So we can just specify the fields we're looking for. I would simply paste these here. Those are really just the same fields that we already have declared here in our search book DTO. So all of these just in a comma separated string. If you're lazy like I am, then you can also just look up this string here in the GitHub repository below. Now the thing is, if we would run this would very likely crash. Even though we don't have any syntax errors, it would crash because what we return here is a list of domain level books. But what this response returns is actually our search response DTO. So typically you have two options when you face this with a data source. It really all depends now whether we want to use this data source application-wide, so also in our view models, for example, also in our domain layer. Because if we would want that, we would need to create an abstraction for it. Because again, if we would now simply use this Ktor remote book data source somewhere in our presentation layer, so if we would pass that here, for example, in our book list view model, this would work. So we would have our data source which is a K2 remote data source. But the moment we do that, we couple our presentation layer to our data layer. And when our data layer faces changes, again, in things like JSON field names, if the accepted data also changes, then that will cause changes in our presentation layer as well, which we want to avoid with this architecture. A data-related change should ideally only cause a change in our data layer. And a presentation layer-related change should only cause a change in our presentation layer. So remember, the directions here of our architecture, the directions of the dependencies, are like this. We have our presentation layer towards domain, and then we have data that also points towards domain. There is no arrow from data to presentation directly or from domain to data. So this would also not be valid if we would want to use that in our domain layer. So what do we do here? We could create an abstraction for this. So we could go in our domain layer and we create something like a remote book data source, which really just provides the function signatures like this, that this data source should have. This actual implementation can then implement that, that abstraction that we've created in domain. Since this way around, it's completely valid. If the abstraction sits in domain, then data is allowed to access that. Since there was an arrow from data to